Now about this EIGRP, what do you think the difference between IGRP and EIGRP? What do you know as the difference between IGRP and EIGRP? Algorithm. And differences, as you said, EIGRP is classless, IGRP is classful. Other variation is the number of bits that are used are not same for calculating metric, but the similarity is same. Just same dual algorithm IGRP also uses. And about the administrative distance, this is 90. Oh, good. External is 170. What about IGRP? Yeah, right. Now, what is external? You said external is 170. I appreciate that. What is it? There is no answer in this statement. Question, you have reframed it. Administrative distance, internal is 90, external is 170. What does that 170 external means? What does 90 internal means? I'll explain. When we learn routes from other router with whose autonomous system is same, then it is internal. When a router learns EIGRP update from other router that belong to same autonomous system, we call it as internal EIGRP. For example, 3333, 2222. When I see in the routing table, I'll see here like this: 2222 190/metric, and then the interface. Likewise, 3333 90/ the metric calculator, and then the interface. It is because coming from the neighbors that are in same autonomous system. Now, let's say I got another autonomous system. It can be EIGRP. It can also be RIP. It can also be OSPF. It can also be BGP. It can also be ISIS. It can also be a static route. When you redistribute them into EIGRP, when you redistribute the routes from another source, not from the same autonomous system, another source includes EIGRP, which is in another autonomous system. So, right. It is any, it need not to be always another EIGRP. It can be RIP or OSPF, GPU, ISIS, any. So, if the autonomous system number is different, it is as equal as coming from some other protocol source. It is as equal as coming from another protocol source. Let's say I have here 4.4.4.4, and it may be from Eigrp 200, or it may be from REAP or OSPF or BGP or ISIS, or it can be a static route. When I redistribute this from static route or any of the source to Eigrp 100, then the route will be learned like this. Yeah, right. So redistributed routes are called as external routes. That's the answer. Redistributed routes or external routes, advertised routes or internal routes. Advertised route means what? We use network command under Eigrp 100. That makes the process to run the network and advertise the network. We call it as internal. Redistribute means taking from some other source. It can be static route, can be RAIP, OSPF, BGP, ISIS, can be any. When you redistribute those networks, administrative distance is going to be 170 in the routing table. Now, let us go to the next question is, the hello packets are not used in RAIP, but we saw that Eigrp uses hello packets. Why do we need hello packets in Eigrp? Mm. To discover neighbor. To discover neighbor, isn't it? To let know my neighbor about myself so that my neighbor can learn me. That's why we say hello when we meet someone, so that that person will come to know about me. So saying hello is to learn, discover neighbor. Not only that, after forming neighbor, the hello packets are sent every, how often hello exactly? Every 5 seconds to let know the neighbor that I'm still alive. Yeah, the dead timer is 15 seconds. Every 5 seconds, the hello packets are sent. If a neighbor stops saying hello for 15 seconds, the neighbor considered as dead. Next, if I change the timer in Eigrp, if I change this hello timer, will the neighborship continue or it will break? How do you say that? How do you say that? How how confident you are? Hmm. Very good answer. So see, OSPF timers must match in the hello packet. In EIGRP, you don't have that constraint. We need to be very solid in this. I'm very happy that you already know it. The timers doesn't need to match, but try to keep same time to have proper sync. That's recommended, but not to form neighbor. It's not a constraint. It's not a parameter to match. Okay, next. Hello packets are sent to which address? Very well said. 10. No broadcast. Eigrp never does broadcast. It does unicast and multicast. To a known neighbor for query and response, it uses unicast. But whenever there is a topology change, it uses multicast to let know everyone about the change. Okay. Another thing is, you already told that, but question was different. But anyway, what type of protocol is the EIGRP? Is it hybrid protocol or advanced distance vector protocol? Advanced distance vector. Why it is not hybrid? Because we don't have sorry, we don't have any traces of link state. When I have some identification is found from RIP like distance vector, some features are identified from link state protocol, then I can call it as hybrid. But when I don't have any trace of any shadow of any similarity with link state protocol, when I don't have any similarity with the link state protocol, the behavior of link state protocol, I cannot call EIGRP as hybrid. Then why people are calling as a hybrid protocol? They simply call like that because this protocol has got three tables, same like OSPF. It has got neighbor table like OSPF. It has got it has got it has got topology table like OSPF, and then the routing table. But that is not a point to qualify a link state protocol. So EIGRP has got no similarity with link state protocol. We can call it as advanced distance vector protocol. The reason is it's not like a RIP protocol. It's not that bad like a distance vector. It is slightly better than distance vector. For example, RIP, if you take, every router will send hop count along with the hop count value along with the prefixes, hop count values. Whereas EIGRP will advertise distance. It won't advertise metric for the neighbor. It won't advertise metric for the neighbor. It will only advertise the advertised distance to the neighbor. What does that mean? Let's say, no, let's say this is you, and this is the final destination, and here I am. Now, if it is RIP, how do you advertise? You will tell me to reach the final destination. For me, it is one hop. For you, it is two hop. So I learn about the final destination with the hop count to reach from you. Completely, whatever you give is what I take. I don't have any work to do here. I just copy whatever you give. You said final destination two hops. I take it, which we call it as learning by rumor. What if you said wrong? What if you gave a wrong information? No, no. Say, for example, what if you set an offset list to manipulate, to change the metric, and you say, for me it is 1, but for you it is 5. Can you do this? Yes, you can. You can do it in REAP using offset list. We do this. Now, what I'll do is I'll just copy whatever you give. I have no option to verify this. Whatever you advertise, I have to take it. That's how a distance vector protocol work. Learning by rumor. What is rumor? It may be right, may not be also. So this is how distance vector protocol works. But EIGRP, which is an advanced distance vector protocol, it is not this bad. You will only say to reach final, my metric is 1. That's all. You will only say my metric is 1. Meaning you are advertising your metric, but you know. For you to reach that final destination, let's say EIGRP metric is 15, you will say, hey, my metric is 15 to reach final destination, which is what called as advertised distance. Advertised distance is the metric of my neighbor. I'm here for my neighbor to reach final destination is 15. But is it my metric? No. It's a metric of my neighbor. My metric, what I do is I calculate. I take this 15 and I add the metric between I am and you. Let's say between I am and you, the composite value is 10. So I am calculating by using your advertised distance as an input, I derive this 25. You see, it's not completely relying upon you. It says, EIGRP says, we are not completely depending on what you give as a metric for ourselves. You give your metric, I'll calculate my own. So EIGRP is not giving 25 as a metric. It says, for me it is 50. You manage to find out yours. That's how it works. So this is one reason why we call it as advanced distance vector protocol. RIP is completely dependent on neighbors' hop count. Did you find the difference? Do you understand what I say? You're mute. Did you understand what I say? Distance vector, we'll talk about that. Now, I did not speak about bandwidth or delay. I just talk about metric. Now you see, RIP says my metric is 1, for you it is 2. Who determines number 2 in IM router? You determine it. I have no control over the metric in my routing table. You gave 2, I just take it. But EIGRP is not like that. EIGRP says my metric is 1. Now I have to calculate the metric between I am and you, and if it is 5, then I'll say my metric is 6. So the 6 is not given by you. You just gave 1, which is your metric to reach the final. I derived my own metric by taking your advertised distance. That's what calls advertised distance. Advertised distance, and by adding the metric between myself and you, I get my total metric. Now, you are thinking about bandwidth and delay. When we say metric in EIGRP, it is composite value. This number 5 here is a composite value derived using bandwidth and delay. For your easy understanding, I took 5 and 1. Usually, the composite metric in the real world will be like 6-digit, 5-digit number, which is the bandwidth and delay. The smallest bandwidth plus sum of delay. We have not gone that far, but I just answered you because you keep on thinking about it. Here, metric, when I say it is a calculated value. End of the day, the bandwidth and delay will not be two separate numbers, it's going to be one number only. It's composite value. Eigrp metrics of composite value. Now, Eigrp is an advanced distance vector protocol. The other reason is they don't use broadcast address to send any advertisement. And also, by default, it supports 100 hops. Metric of Eigrp is not a hop count. As you said, it is bandwidth and delay. It is not a hop count. Then why are we talking about hops? See, Eigrp has got some limitation. It is a protocol comes under IGRP. Sorry, IGP. It's a protocol coming under IGP. IGP is a global term, which means the protocol to be within the autonomous system, within the enterprises. Is this a service provider protocol? No. It's a protocol that to be used within the autonomous system. IGRP, Interior Gateway Protocol. But nowadays, enterprises is also too big. What does it mean? More routers, more routers, more routers, more networks. Eigrp will struggle to manage. To avoid, to be on safer side, Cisco has said only 100 hops by default Eigrp will support. 101th hop, meaning 101th router, not reliable to use IGRP. But if you have less number of networks, even though you may have 150 routers, 150 hops, if you know that you don't have thousands of network, though the hops are more, networks are not that many, then you can increase this hop. You can increase this hop to 255. That's the max. That's the limitation. That should be limit for everything, right? There is nothing in this world which is unlimited other than galaxy. There is nothing on this earth where you can find unlimited. Everything there is a limit. For anger, there is a limit. For joy, there is a limit. For everything, there is a limit. Even if you buy a big aeroplane, there is a limit. You cannot fly over some height, maximum like 35,000 kilometer high, feet high. A normal domestic aeroplane flies 35,000, 38,000. I have seen. I have not seen any flight in my life journey going more than 38,000 square feet above, whether it is international or domestic. So, and for everything there is a limit. Even if you buy a rocket, there is a limit. Spaceship, there is a limit. So Eigrp also has got a limit. But you know what? OSPF claims unlimited hop count support. When we go there, we will discuss that. Now, EIGRP, 100 hops by default. But can we increase it? Yes. Answer is yes, you can increase up to 255 hops. Next, EIGRP is a classless routing protocol we learned, which means it supports VLSM. EIGRP supports multiple network layer protocol like IPX, AppleTalk. It has got an independent module for each protocol type, network layer protocol. And then we saw the last point like this. EIGRP can support unequal cost load balancing. Unequal cost load balancing, meaning I have 10 kilogram of sugar in my hand. Now I call my daughters, two daughters, and say, okay, you carry 2 kg, you carry 1 kg. So now I'm carrying 7 kg. My first daughter carries 2 kg. My last daughter carries 1 kg. You see, unequal cost load balancing, meaning unequal capacity is not same. My capacity and my girl's capacity are not same. They are kids, they can't carry more. My elder one claims she's stronger than me, so I give her 2 kg. Enjoy, carry. The small one, cute one, I give 1 kg. And I carry 7 kg. Likewise. Routes of different metric, not same metric. When I share the load 7, 2, and 1, we can walk long distance and we can cover the distance faster. Instead of me carrying all 10 kg, when I share my load, they also have something to focus, to take care. They're not feeling bored of walking with me when they carry the bag of sugar. Their focus is on walking as well as on the sugar. They're not feeling bored now. And also we reach the destination early when we do that load sharing, because I don't need to carry 7 kg, sorry, 10 kg, which will make me tired early. 7 kg is going to give me some extra walk. Same way. When I have multiple paths of different metric, different composite value, different metric. Let's say this has got 15, this has got 18, this has got 21. By default, any routing protocol you take, it will take the least cost path, low cost path, low cost path. But EIGRP can even take these two routes and it will share the load according to their capacity. For example, here it sends like 750 packets. Here it sends like only 500 packets. Here it sends like 350 packets. So instead of one link sharing, carrying all this 1,000 plus traffic, almost 2,000 traffic, when you do load sharing, it can reach faster. It can reach early the destination. Unequal cost load sharing is supported in EIGRP. No other protocol support this. But by default, this is not enabled. All protocols supports equal cost load balancing. See, any protocol you take, it will use both the links. Like if there is 1,500 packets, then 750 will be on the upper link and the other 750 will be on the second link. Yeah. So equal cost load balancing. This is available in every routing protocol, RAPE, EIGRP, OSPF. Up to 4 paths it can use by default. By default, RAPE, EIGRP, OSPF, all these protocols can use 4 equal cost paths. If you want, you can increase up to 16, depending on the version again. But by default, 4 equal cost path is supported in every routing protocol. And the load sharing will happen automatically. This we call as equal cost load balancing. But only in EIGRP, we can even use these paths, but this option is not turned on by default. By default, even EIGRP can use only these two. By default, EIGRP also supports only equal cost multipathing. Though we say EIGRP supports unequal cost load balancing, it is not turned on by default. We need to turn on a bit called variance. We will see this later, maybe in the second or third chapter it's coming. Variance. By enabling variance, we can do load sharing. What load sharing? Unequal cost load balancing. Unequal cost multipathing is only after we enable variance, not enabled by default. Up to this level is what we covered in the previous class, correct? Okay. Manual summarization also we saw. We will be seeing it again. But before that, as we already spoke, hello packets are sent every 5 seconds. With the help of hello packets, neighbors can be discovered. And not only that, when a neighbor goes down and comes back, you rediscover it, meaning you recover it. It's hello packet. Maintaining neighbor is also hello packet. I should say discover slash maintain slash recovery. That maintain word is not there. Next is EIGRP. On which layer of OSI it works? IP. It is an IP layer. What is IP layer? Network layer. Correct. Layer 3 protocol. EIGRP is a layer 3 protocol. EIGRP works in layer 3. IP layer. Meaning this protocol will never use UDP or TCP for transport. This neither uses TCP nor UDP. Then what is used? EIGRP has got its own protocol called RTP. It's not TCP, it's RTP. Reliable Transport Protocol. When I say RTP, sometimes I myself accidentally say real-time protocol. That's a very popular protocol for voice. Real-time protocol is also RTP, but this is Cisco protocol RTP. Cisco protocol RTP is Reliable Transport Protocol. This is the mechanism through which EIGRP delivers the packet with no loss, no packet loss. EIGRP uses its own three-way handshake mechanism using this RTP. See, Reliable Transport Protocol guarantees ordered delivery of EIGRP packets to all neighbors. So first of all, neighbors should come up. Using hello packet, neighbors are learned. Once the neighbor is learned, it is going to use the neighbor's IP address and send the RTP packet. Using RTP, the EIGRP route informations are delivered, and the acknowledgement also comes once the delivery happens. RTP protocol. Next is about the dual algorithm. This is the algorithm that is used to pick best path for every destination. Best path. Based on what best path is selected, low cost. The path with the lowest cost is the best path. Low cost path is a path which don't have loop. Low cost path will not have loop. So how do you say that? Let me give you an example. You have 5 bikes and you have given 5 bikes to 5 different people. And now when they come back, you check the amount of fuel consumed by each bike. The one with the lowest fuel consumption is a person who did not roam around simply. You give them a work, 5 bike you give to 5 different people and give them one work. Same work, all 5 people should go deliver something and come back to the same destination, assume. You clearly tell them, don't go anywhere, don't roam around, just go deliver and come back. And now when you see the fuel consumption level, you can say who has roamed. Whoever has simply roamed here and there after delivery or before delivery, the cost would have been gone high, means the fuel cost, because more roaming, more fuel consumption. Low fuel cost, meaning he didn't roam anywhere, delivered and come back. Same way here also in EIGRP. If any path is looping to a destination, if you have a looping path, the metric will keep incrementing because it's looping path. Looping path will always have unstable metric, unstable cost. Cost will be slowly increasing, which means looping will not be the same always. See, the dual algorithm uses something called feasibility condition. I'll be explaining you this in maybe another two pages after, but still I'm just introducing now. Dual algorithm uses something called feasibility condition. Using the feasibility condition, it can select a loop-free path, a low-cost path, and an alternate loop-free path. Dual algorithm can select a low-cost path, which is the primary path, and a backup path, which is also loop-free for each destination. To select the backup path, loop-free backup path, it uses a technique called feasibility condition. Feasibility condition is nothing but the successor value should be less than the advertised distance of the backup path. No need to worry about it now. Let's go to the next. As we already spoke this point in the previous class, It is independent modules are available for Apple Talk, for IP, for IPX, which is nothing but novel network. These are all network layer protocol. These are all layer 3 protocols. For all this, you have a separate package, separate module. They are independent of each other. If you are using IP, you need to depend on the IP module. You should not use IPX module or Apple Talk module. As we already spoke, Eigrp has got 3 tables, neighbor table, which will have list of neighbors, directly connected neighbor. The directly, when I say directly, it need not to be always physical. It can also be via a tunnel, but that is too much for now. What I'm trying to say is established neighbor. Neighbor with which hello packets are sent, discovered, and so on. Neighbors. List of directly connected router running Eigrp with which the routers have adjacency. What is adjacency? After two router forming neighbor, they synchronize the database by sharing what they have. By sharing what they have, they synchronize and form adjacency. That is what called as neighbor table. The table that has got the list of neighbor with which adjacency is formed. Okay, this is it. Very important page, especially this feasibility condition. This is what feasibility condition here, whatever written in the bracket. The advertised distance of the feasible successor must be less than the feasible distance of the current successor node. It will be difficult for you to understand now, but in few minutes you are going to understand this in a very easy way. So for that we need to start from the top. Diffusing update algorithm is responsible for picking the best path for each destination we saw. The best path should be a low-cost path, also a loop-free path. The best path should be a low-cost path as well as the loop-free path. How do we guarantee this loop-free? It's going to come like the following. Now, before that, we have to understand these terms. Advertised distance. Can you tell me what is advertised distance? We already spoke in this class, the beginning. Exactly. Advertised distance is the metric of the next router, immediate neighbor to the final destination. That's what here also it is written. You see, cost between the next hop router and the destination. Fine. Next, what is feasible distance? Feasible distance is nothing but the total distance. The cost from the local router is what called as feasible distance. Total distance, cost from the local router to the destination, which is also equal to advertised distance plus the cost between the local router and the next hop router. Is it easy to understand, FD? Let's read again. Feasible distance is equal to cost from the local router, which is calculated like this. Advertised distance meaning the metric of my neighbor. That's what advertised distance. Metric of my neighbor plus The metric between myself and the neighbor. The cost between the local router and the next hop router. That is feasible distance. These terms are very important. Advertised distance, feasible distance. Now, you may be having multiple paths. To reach a destination in the internet 1.1.1.1, this router 1 has got path via router 2 as well as via router 3. Now let us say the advertised distance from here is 15. The advertised distance from here is 18. And the metric between R1 and R2 is 10. The metric between R1 and R3 is 11. Now, R1 has got two feasible distance. R1 has got feasible distance via router 2 is 15 plus 10, 25. Feasible distance via router 3 is 18 plus 11, which is 29. How many feasible distance? Two feasible distance. Now, what is low cost? The lowest feasible distance. This is the low cost path via router 2. This is the low cost path, which is also called as successor route. Low cost path is the successor route. The successor route is equal to the next hop router with the low cost path, low free path. I told you low cost will never have loop. Now, we are learning successor, the word successor here. Successor is nothing but the path with the low cost, lower FD, feasible distance. Did you understand this 2FD from R1? 2FD. And then lowest FD is the successor. So, feasible distance is not successor. Feasible distance is not successor. Lowest feasible distance is the successor. Lowest feasible distance. Sometimes, some people say successor and feasible distance interchanging. No, that will confuse. The low feasible distance is the successor. The low feasible distance is the metric of the successor route. Via router 2 is the successor route. Next hop router 2 is the successor route. Now, what is feasible successor? This is the important point. Very, very important point. So, are you clear with the above 5 points? Okay, now let us go to the feasible successor. I just told successor is nothing but the primary path, the elected path, the low cost path. Now, in our case, going via router 2 is the primary path. This is the elected primary path. Now, to choose R3 path as a backup, backup is nothing but feasible successor. Feasible successor is a term given to backup routes. See, to become a backup route, there is a criteria. Not every route can become a backup route. My father was a forest ranger officer, but his son to become a forest ranger officer after he passed away, there is a criteria. Because I am born as a son to my father, I am not eligible if I am not having that equivalent education degree, isn't it? If my father is a forest officer, if I need to become a forest officer after him, I should have that education, which is very important. I cannot be one LKG or first standard graduate to become a forest officer. I should have that that stamina, that strong physique and the tall and education. Only then I can become a feasible successor. Only then I can become a backup. Likewise, for R3 path, for the router 3 path to become a backup path, there is a criteria. Only if that criteria is met, it can become a backup path. Otherwise, router 1 will not install into the topology table as backup path. I repeat, not all paths, available paths can become a backup path. Only those paths that meets the criteria can become a backup path. Only those paths that can meet the criteria can become the backup path. Yeah. Now, what is the criteria? The area of whom, area of the backup path should be less than the successor value. You see, the area of the backup path should be less than the successor value. If there is a loop, this won't be possible. This area will keep incrementing if there is a loop like this. When there is no loop, then it is possible. This is how dual algorithm provides a loop-free backup path. See in the bracket it is written, area of the feasible successor, which is nothing but the backup path 18, must be less than the FD of the successor, which is nothing but lowest FD. 18 should be less than 25. If yes, yeah, it is true. Now you will see in the router 1's topology table, primary path, which is called a successor path, and the feasible successor path for the destination 111. Yeah, backup path. Now, when the successor goes down, this will be promoted to the routing table as a successor path. This feasibility condition is what dual algorithm uses. How dual algorithm can guarantee a loop-free backup path? By using feasibility condition. It's very important. Feasibility condition. Any question in this page? So we have learned about neighbor table. We have just learned about topology table. Topology table will have all destination, and for that destination, the successor route, which is nothing but feasible distance. Sorry, correct. Low cost path, which is nothing but the successor route, low FD value. I don't want to write FD. Successor route as well as the feasible successor route. If there is no feasible successor, it won't have. There may be a backup path, but it is not satisfying the feasibility condition. Then you cannot see that in the topology table. Now this is routing table. Every routing protocol will use this routing table. Eigrp also uses this. Only the best path, only the successor path will be installed into the routing table. Only the successor path, no feasible successor, only the successor path is installed into the routing table. Now I want you to go through this, and if there is any question, you ask me. Correct. This is Ethernet 0, and this is 1500, which means this is 1000, because I see FDS 2500, and this is 1000, and this is 1000. Right. So in the routing table, you see the path with the low FT. So the primary path, the elected path, the successor route is this, which is there in the routing table. This is the feasible successor route, which is also along with the primary route in the topology table. Topology table will have both. Now, packet types in Eigrp. 5 packet types: hello, update, query, reply, and acknowledgement. In order to discover neighbor, establish neighbor, hello packets are important. Sent and received every 5 seconds. Updates are sent whenever there is a new route coming in or a new neighbor discovered and routes are learned from the new neighbor. When a link goes down, then also it is notified as update. Queries are okay for the update. When you send me an update, I send an acknowledgement. For every update I receive, I'll be sending acknowledgement. Next is query. For example, one successor has gone down and there is no feasible successor. What will I do? The successor has gone down and there is no feasible successor. What I'll do is I'll start querying the other neighbors for route information. And if the neighbor knows the alternate path, they will respond me. They will reply me. So for every query I send, I will also get an acknowledgement from all the neighbors who received it. Likewise, when I get a reply, when I get a response to my query from my neighbor, I'll also send an acknowledgement. Right, these 5 types of packets we see in Eigrp, except hello. Except hello, for update, query, and reply, there will be always an acknowledgement. It's the same thing explained here. You see these routers are sending hello packets. A is sending hello, and B learns about A, and B now sends hello as well as the update. Now A learns the new topology, means the new destinations from B. Before that, it sends an acknowledgement for the update, synchronizes its topology, and also it now A will send its own update that gets updated in B. Before that, an acknowledgement is sent to A. Now there is nothing more to share between them. They're converged. So except hello, if you see, for acknowledgement, sorry, for updates, acknowledgements are sent here. Metrics in EIGRP, there are five. Five metric in EIGRP. But later they reduced to two. The reason is too much of anything is good for nothing. How is that possible? In a highly high traffic area, you cannot have a car which can accommodate seven people. You want a car which will take you to all the malls in a less time, and that car should accommodate seven people, and then the car should not be too fat, it should be thin, and then the car should not consume much petrol. Not possible. Too many parameters. To reach faster in a city area, you need a small car, which means you need to compromise with the head counts. You cannot have seven-seater, two-seater car. So initially, EIGRP was designed by someone who wants everything in one car, which is not possible. They found it is not possible, so they made it to see bandwidth and delay. These two are considered now. Reliability, load, and MTU. If you want, you can enable them to be considered, but by default, low cost path means the path with more bandwidth and less delay. Bandwidth and delay are the two components in metric considered. So when someone is asking what is metric of EIGRP, answer should be like this. Yeah. Smallest bandwidth plus sum of delay. That should be our answer. Smallest bandwidth means what? Smallest bandwidth plus sum of delay means what? But that is what the answer should be. But before we know the in-depth of that answer, let's finish this remaining stuff mentioned in this page. If you see here, there it is mentioned the difference between EIGRP and IGRP with respect to metric. As I said, EIGRP metric is 32-bit. IGRP is only 24-bit. How many bit extra? 8 bits extra. EIGRP is 32-bit. IGRP is 24-bit. What is the difference? 8-bit. 8-bit, what is the face value? Face value. If all the 8 bits are on, what is the decimal value you get? 256. 256. Yeah, 256. See, that is why here it is said to get EIGRP metric from IGRP, you need to multiply IGRP metric by 256. Multiplying IGRP metric by 256, you will get EIGRP metric. The reason is EIGRP metric is 8-bit extra more than IGRP. IGRP is 24. You see here, IGRP is 24-bit. EIGRP is 32-bit. So if you want to get EIGRP metric from IGRP, multiply IGRP metric by 256. If you want to get IGRP metric from EIGRP, then divide by 256. Anyway, this is an useless conversation. The reason is we don't have IGRP anymore, right? No need of. Now let's go back to this. Metrics, though we have five metrics, bandwidth and delay are considered. Why not reliability and load? Reliability and load are flexible, means variable. Reliability and load is variable. They're not same. They're not same all the time. The reliability and load will not be same all the time, but bandwidth and delay will be same. If I take a wire, manufacturer says this is 100 meg wire. It will be always 100 meg. It won't come down to 80 meg, and it cannot go up to 200 meg. Not possible. That catalyst, the category 6 cable or 5 cable, cat 6 or cat 5, the manufacturer has clearly mentioned it is 100 meg, which means that is how it is manufactured to support 100 meg. That won't go up or down, but load will go up and down depending on the traffic. Load on the wire will be different in different time. Okay, let's take a road. You have 100 feet road. 100 feet road is 100 feet road. Will it increase or decrease? No. But the people who uses the road will be more sometime, less sometime. Load will keep varying. During the peak hours, the load is full. In the midnights, not much. Load will vary. The users of the road are not same in all time. Changes time to time. So when there is heavy traffic, is the road reliable? When the traffic is heavy, is the road reliable? No. It is not guaranteed that you will reach the airport on time if you trust that road because the traffic is heavy. Same road in the midnight, you can relay. You can trust that you can reach on time to the airport. Right? When there is a heavy load, reliability goes down. When the load is less, reliability is high. But that is not the case with the bandwidth and delay. Delay and bandwidth are constant values. When we purchase wire, it is very clearly written how much delay it will take for a traffic to go from one end to another. That delay is constant. Say, for example, you take a metro train. Very clearly, it will show you will reach the station in 20 minutes. By 20 minutes, you will be there. But you cannot guarantee that in a bus or in a cab. But in metro, you can guarantee the delay and delay. You can be sure that in 20 minutes, if it says 20 minutes, the fourth station will be reached by 20 minutes. If it says you will be reaching by 20 minutes. Short. Likewise, the delay in the wire is also constant, but the reliability is not constant. Did you understand the difference between delay and reliability? No, because the reason is why I'm emphasizing on many people are confused with load and bandwidth, reliability and delay. Bandwidth is not load. Bandwidth is always same whether there is a load or not. Whether there is a traffic or not, bandwidth is same always in the wire. That's a constant. But the load will vary time to time. In the mornings, everyone goes to school, people go to office. Load will be high, so reliability will be low. Because more delay will happen, you see. That delay is reliability. But delay in a wire, whether traffic goes or not, to go from point A to point B, there is some time taken always. That is called delay. That delay is not reliability. What is maximum transmission unit? Maximum transmission unit. How many bit or byte you can transfer per second at a given point of time? This is also a constant, like bandwidth and delay. MTU is also a constant. But MTU is not considered because we already have two constants, bandwidth and delay. Answer to this question, why reliability and load is not considered? Because they are variables. They change time to time. Are you clear? Shall we go to the next one? Right. Now, you see the first line in the red one. What is metric? In Eigrp, slowest link bandwidth plus sum of delays. Other things in this page is not that important. Only the red one is important. Slowest link bandwidth plus sum of delay. Why the other things are not important? Other things are not important because it's zero. Anything you multiply by zero is zero only. This is MTU. This is load. This is reliability. Only K1 and K3 are considered. K1 is bandwidth, K3 is delay. Right. Now, this is what it is an explanation for the previous page. What is the metric of Eigrp? Slowest link bandwidth. Slowest link bandwidth. Now you see, in this path, the slowest link is this. T1 means 1500 kilobits. That is T1. This is only 64. That is why that is considered. You cannot consider the high speed links bandwidth. So if you consider this, then all the packet will go according to T1 and get bottlenecked here. Is it? You understand that? Yeah, it will become a bottleneck there. So how Eigrp calculates this end to end, it sees and takes the bandwidth of the link which is having low bandwidth plus addition of delays 2000, 6000. Yeah, so that's what it means. Low cost path in Eigrp means slowest link bandwidth plus sum of delay. Not that important, these things. Anyway, if you can remember, it is 10 to the power of 7 divided by bandwidth into 256 gives you bandwidth. These are all algorithm. Inside algorithm, inside the Eigrp D1 algorithm, you have this. This is how it derives the number. Right. So in this chapter, we learned a very good introduction to Eigrp. In what way it is different from normal distance vector protocol, and we learned a lot of terms like administrative distance, advertised distance, feasibility distance, successor value, feasible successor, successor route, difference between metric difference between Eigrp and Eigrp, and how the metric, the composite value is calculated, etc. Right. So in our next